Hello scientists, and welcome to our Explore video for gravity. Alrighty, so what I want you to look at first is here we have a little magnet and we've got a paper clip attached to a string. So when I hold the paper clip around this magnet, what do you notice starts to happen? Go ahead and answer below. Okay, so you might have said that the paper clip is attracted to the magnet, right? We know that's a property of metal, that it's magnetic. But what it's doing here is being drawn toward where that magnet is. Now, gravity on Earth is very similar to this little simple demonstration. Let's say we are somewhere near the equator. So if we're in, I don't know, where should we go, guys? Let's say we are in Venezuela, and that's, close to the middle of our Earth or the equator. Well, if you think about it, they're on the side of the Earth. How do they just not topple off? Well, check this out. If this is representing the pull of gravity toward the Earth's core, and this little paperclip is representing people, then when I am close to that paperclip, it is drawn toward it's drawn toward the core of the Earth.
All right, it looks like all of our buses have arrived. Miss Diana from the office is going to start dismissing you very shortly. Everybody have a wonderful evening, and we'll see you back here tomorrow morning.
Okay, so similar to, think about our penguins down in Antarctica. They're at the bottom of the Earth. Why don't they just fall off? Well, if we use our little magnet as the pull of gravity, and now imagine this paperclip is a penguin. And if it pulls toward the bottom of the Earth like that, then the force of gravity is keeping all of us on Earth, which is good because we could not float off into space and survive. Now, it's because Earth is so massive that we are able to stay in the gravitational pull. And you can relate that to the Earth and the sun as well. So we are very small compared to the Earth, but the Earth is still small compared to the sun. The sun is very, very massive. And so because the sun is so much bigger, our Earth is in that gravitational pull, which is great because that keeps, we're the perfect distance away for sunlight and life on Earth. Okay, so we're gonna switch over to another little activity and I'm gonna show it up on my screen. So you can see here we have a little chart and here is the distance. So moving farther away, does the paperclip move to the magnet? So I'm gonna show you a little experiment. We're gonna go from 15 down to 0, and then we'll go 16 up to 30. So looking at this, I've got this right at the 15 mark right here. And as I move it away, we're just gonna be saying yes or no if it moves to the magnet. Well, if I'm at 16, obviously you can see the pull of it. Yes, it goes. And then, we're going down. So 15, yes. 14, yes. 13, yes. 12, yes. 11, maybe not 11. There we go. 10, 9, 8, and so forth. So those are all gonna be 0. But if 12 is our cutoff there. Alrighty, so if I go to my other side, 16, yes. 17, yes. 18, yep. 19, so that's about the distance. That's a little bit too far for this magnet to pull it. 20, 21, and so forth. We know the rest is going to be no. So what you might notice is a little chart over on here. And so we're just gonna mark when it would move toward the magnet. So at 15 to 12, yes, 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 yes. And then at 11, from here on out, it was no. So we started to get too far out of that gravitational pull or the magnet pull. And so it would not. And then over here, 16, yes, 17, yes, 18, yes. I think 19 was a little bit, let me double check. Oh no, 19 went slowly, but it did actually just now. So yes, and then we've got no all the way down. So you can notice that the closer the magnet is closer the paperclip is to that magnet, yes, it will pull towards it. It jumps out of my fingers and goes to the magnet. And then the farther away we get, the less power that force of that magnetic force has, which is very similar to our gravitational force. So what I'm going to do is put a couple questions up on the board and give you some opportunities to answer them on this Edpuzzle. So how is this model, our paperclip on our ruler, similar and different from what happens in the real world? Go ahead and take a minute, pause and think about how is that magnetic force similar to our gravitational force? How is it different? Okay. What did you notice about the paper as the paperclip moved farther away from the magnet? So when it got farther away, what started to happen? Alrighty, and our last question. What does this tell you about Earth's gravity? So relate what happened as you moved that farther away to Earth's gravity. What do you think? How does it relate? All right, boys and girls, excellent job today, and I will see you tomorrow.